Hi, chemistry students. Here we're going to talk about a scientist by the name of Niels Bohr and kind of some of his contributions. A lot of chemistry classes actually use his model of the atom still. We know that it's not accurate, but it's actually a good representation, something that's like easy, you can draw a picture of, and it kind of gets us away from some of the more difficult kind of recent discoveries with an atom. So basically kind of the problem. Remember, we're kind of at Rutherford's model, the planetary model, where you have this little nucleus that I kind of indicated here, with these little electrons that are kind of like whipping around and orbiting. Now, physicists have a huge problem with Rutherford's model. He proposes this model, but it falls kind of apart very quickly, and the reason why is because classical physics says that basically that electron is going to spiral down into the nucleus, and the two are going to basically eventually get stuck together. It's not going to just keep orbiting. When it does that, it should be releasing light as it goes. And I mean, so classical physics says, hang on, according to what your model is, I know that it's really small, but it doesn't work. So this guy by the name of Niels Bohr came in. He was a Danish physicist, and he ended up winning the Nobel Prize for his work in 1922. He was a young guy, but he had a lot of critics in the scientific community. What he basically found out is that atoms, when you excite them by kind of adding light to them, what happens is, or what he theorized is that electrons kind of jump up on these different kind of like energy level things. And then, so you could excite the electrons, and then when the electrons are unexcited, they release light. And he studied light and was able to basically predict light patterns for different elements. He was able to say, hey, this is how far like the electrons are from the atom. Now, so what his model of the atom was, this is the thing that you would want to sketch from Bohr, is that you had a small nucleus, and then you had kind of these little concentric rings. These are what he called orbits. And he said that the electrons have to be in one of the orbits. So they go around, but not like Rutherford stated. He said that they went around in these very neatly defined paths, and that they could jump from one path to another path if it either emitted light as energy, and so it went down to a lower energy state, or it could go up in an energy state if it gained energy. This is the model of the atom that most chemists use, because it's actually really easy, and it totally predicts why atoms behave the way that they do. Now, where he had all this criticism was that in the model of the atom, he basically said it works, but I mean, he's kind of like coming up with these arbitrary rules, like it can jump from one state to another, but can't ever be in between. And so, like, physicists like kind of asked the question why, and he didn't really have an answer. He just said, well, it just does. And so it was kind of he ended up having a lot of critics of his work, because they all said, well, yeah, because all you're doing is you're writing rules to describe the way that things are. You're not explaining why. You're just saying that it is that way. And to an extent, he was right. It does work that way, but scientists didn't like not knowing why. And they also didn't like that he didn't really have a very good concrete evidence. He was looking at light, and people knew that light wasn't made of atoms, and so that kind of gave him a lot of critics. Now, Niels Bohr, he's got a kind of an interesting story, because he was very involved in science and kind of in mankind, because when he worked in Europe, he did some work in Germany. That was one of the labs that he worked in Copenhagen. And what happened was a scientist by the name of Heisenberg, who he came around and he had his contributions to the atom too. He worked for Nazi Germany. He was a German scientist, and Niels Bohr was like one of the leading physicists on atoms. And so when research was happening in terms of like nuclear energy, and maybe there's a possibility this could be turned into a bomb, Heisenberg kind of said, hey, this Bohr guy, I've worked with him before, he's someone who we want on our team. Bohr found out that Heisenberg wanted him to come and be part of basically the German nuclear research project. and he fled the country. He ended up in England, where he got hooked up with, in this picture over here on the left, this is a old Einstein, and this is an older Bohr, and the two of them worked together on the Manhattan Project, where they actually developed the atomic bomb. So Bohr was like a big proponent of, he didn't want there to be like nuclear weapons. He wanted to have those, but he also saw that, I mean, that these other countries are working on it, and that we needed to have kind of the right minds to have that power. So he kind of played a big role in, I mean, he fled the country, and he also, with him, was able to evacuate a lot of Jewish people that were going to be kind of invaded because of Nazi Germany. So he was also a humanitarian. He doesn't get enough credit. Originally, Einstein here and Bohr, they were kind of like arch rivals in terms of their philosophies on science. And then the Manhattan Project kind of brought them together. They worked together. All right, that's it about Bohr.